Hello everyone, this is Carl and I'm going to walk through how to run the encode attack seek pipeline on Truel. So here I am on Truel.com. I'm going to go to workflows at the top and I'm going to click on this tag over here that says encode to limit my choices down a little bit. And there I can see the encode attack seek pipeline right there in the lower left. The little green arrows indicate that this pipeline is runnable directly on the Truel platform. So I'm going to click on that workflow, and what I get is an overview of the pipeline. I have a link to the GitHub code repository. It shows me that Jin Lee is the owner of this workflow, and he's the author on the GitHub repo as well. So if I want to run this, what I have to do is go up here to fork, or which we'll say new experiment soon enough, and I can hit that, and if my account's configured correctly, it'll ask me to give my experiment a name and a description. I'm just going to leave it as it is and hit done. And what that now gives me is this input editor with all the fields blank. You get this little pencil icon where you can change these, and these are separated out by tabs for different values. And there's a lot of things here and a lot to go out. If you hover over these, it will pop up some help text to tell you what these parameters mean. But it is a bit overwhelming, so I don't want to start from scratch. I'm going to go back, and rather than starting a new experiment from scratch, I'm going to navigate over here to the Usage Examples tab. And what this gives me is a list of publicly shared examples of this experiment. So here's one that's subsampled to 1/400th of the original amount of data. So that's kind of would be a good one to try out as a first step. Here's one that's a bit of a test. Go down. This one, if you look at this jobs field here, you can share what people have saved in their input editor along with completed successful jobs. This one has a completed job with it. It says it was run successfully here. If I look at the reference, if I wanted to run a human sample, this uses HG38, so this might be a good one. And you can continue to scroll through these and see what's available, and it might be closest to what your experiment is. And when you find one, you can hit this fork button, and you give it a name and a description. I was going to say rerun 2 because I've rerun this before, and hit done. And now I have my very own editable inputs that I can change to whatever it is I need to put in here. So this first tab is just pipeline metadata, so you can give the experiment a title and a description. These are text fields, which you can change, and then hit the check mark when you're done. If you don't want to lose your work, you can always hit this save button here. Now, the next tab over is reference genome. And what we have here, a whole bunch of parameters, but you see only one is filled. And in this case, that's genome TSV. And the reason there's only one is this is a tab-separated values file that actually has all these parameters just in a table, more or less. And so I downloaded this and popped it up in a Google Sheet so you can see what this looks like. So all those fields that you see over here in the input editor are just laid out here in this file in one place. And this is really useful if you're going to run a whole bunch of experiments. You don't want to be filling in these values all the time. So having it just in one place is a great way to go. In the GitHub documentation, in the encode repo, it does actually give you several URLs for kind of standard TSV files that the encode project uses. So there's one for HG38, and for mouse there's MM10 and MM9, and there's also HG19 TSV files for kind of these standard references. And there's instructions in that repo if you want to generate your own for some other genome reference. So it's usually easiest just to specify a TSV file if it's available. You can still fill in these values if you want, and anything that you enter here will override what's in the TSV file. So say if I wanted to give a different blacklist, which is a bed file of regions that will be filtered out, I could provide that here, and it would take precedence over what was ever provided in this TSV file. And I should say, even though I copied someone else's experiment, well, actually, I think this might have been a copy of mine, you don't need to go and stick this file in your own bucket somewhere. You can just use it from where it already lives. The system can access it, so you don't need to be making copies of references. Okay, so the next tab is input genomic data, and this is where you specify your experimental data. The first parameter here is paired end, and this can be set to true or false, just a little toggle switch here. In this case, we're going to leave it as true. If you have data that you have some paired end and some single end, we can actually clear this out, and you want to use this next parameter, which allows you to specify an array. So there's this little, once you edit it, there's this little plus button here, and you can add multiple booleans here. So you can mark, for replicate 1 true, 2 false, 3 true, etc. If you have a mixture of those, I'm going to clear that out and reset it and set this back to true, because in this case they're all paired end. And what we have here are, for replicate 1, you can put in read 1, you can put in an array of replicates here. So if this just kind of truncates off the full URI, but if I hit edit here, this gives us the full URI to where that file lives. And so these are read ones, these are paired end. I can open up, look at information for read 2, and these need to be in the same order. So here we have SRR 7064070 in the first row here, and so 4070 in the second row. These look like read ones match up with the read 2s. They need to be in the right order. So we're going to leave those as is. These are in Google buckets that are accessible to the system. So you can provide any publicly available URI to data, and our system can access it, whether it's in Google or in S3. You can also work with us, and you can give access to more to private buckets, just to a service account in our system, where our system can then access it as well. So if you have a bucket somewhere that you just want your data to live and you want to be able to compute on, you can work with us to make sure we get access. And the next tab then is adapter trimming. So this gives you a place to put adapter sequences. Often you'll have this auto detect adapter set to true. So by default, this is false. So when you set it to something that's other than the default, as in true, it kind of changes from gray to black. Alternatively, you can actually provide those adapter sequences. So in here, pipeline parameters, this pipeline you can run as ATAC-seq or DNA-seq. So here it's set to ATAC. You can switch to DNA, so we're going to leave it as an ATAC-seq experiment. If you want to just align only and not do peak calling, etc., you can do that here. You can really choose what the workflow does by changing these to true and false. And once again, you do get kind of some pop-up help here. One more thing I want to go back to is that in your input genomic data, the pipeline or workflow can also start from multiple places. So in this case, we provided the FASTQs, but if you already have them aligned, you can provide the BAMs as well and start from that point. So you kind of have multiple entry points to this workflow. Okay, and then in the alignment tab, you have some options as well. These are typically just left as defaults, but you can kind of go through and see what all these mean. And then in the peak calling, same thing here. You can have a cap number of peaks. Smoothing windows for if you're using the max 2 peak color, which I believe it does by default. And finally, you have resource parameters. So this is where you can specify the number of CPUs, the amount of memory, et cetera, for each step. It's usually fine to leave these as defaults. With this particular run, I think I bumped up against the limit, so I had to set this to 2, where the default is 1. Let's go back up to 2. And oftentimes, oops, I think I went to 4. We'll go back to 2 yet. Got a little, we can bump it up that way too. Okay, back to 2. So what you might want to do is just kick off a job, and it'll fail if you don't have enough resources, and you can look that up and bump that up, and you're not going to lose any progress you made as the calls are cached, so it can re-enter without having to re-compute anything if you have to do that. So, and if you're going to do a lot of runs, it might be worth looking at the logs of your initial runs to be able to tune these parameters, see if you're really using all the resources you're allocating to it. Okay, and once that is ready to go, you can just save it and use it for later. I should mention that as you're filling in these inputs, what it's doing is it's generating this inputs.json file, which looks like so. If you happen to have one of these already and you don't want to use the input editor, maybe you have some script or something that generates these for you, and you still want to run True, that's perfectly easy to do. We have this upload button, and you can drag and drop an inputs.json file right in here, and then it'll populate all these parameters right in the input editor for you. So I'm going to cancel out of that for now. And I think it's ready. So you can now just hit run. And it says your job is launched. We can go back to click on that to view on job detail, which we can also get back to from jobs over here. This one's in the submitted state. I can go and look at this job detail page. Still submitted. That'll kick over to running here in a moment. And it'll send you an email when it's finished. One thing I do want to mention, if you need help running this, have any questions, feel free to find us on Slack. So if you go down to the lower right here, there's a Slack workspace link that goes to our Slack workspace. You do need to be given permission to be in that community. And to get on there, all you need to do is just go over here to the Contact Us page. You can either email us directly at info@truel.com or write a message here saying, hey, can you please add me to your Slack workspace? My email is xyzuser@domain.com, and we'd be happy to have you there, and you can interact with our developers and other users as well. I am going to go over still and submitted. That should kick over at any point now. Oh, and now we're running. So that's good. And once it starts running and starts getting metadata back, you can actually start looking at all this metadata that's being generated as these jobs are launched. Thanks for watching, and we'll see you next time. Bye.